Hey guys, welcome back. So today I've got something a little bit different. Usually you see me repairing generators that have been neglected and in non-running condition, but every once in a while a generator manufacturer gets the idea to send me one of their new generators for review. And that's exactly what happened in this case. A manufacturer named ERAYAK sent me their inverter generator and asked that I do a fair and honest review. So that's what I plan to do. Let's get it out of the box, check out the features, and put it to the test. Yeah, before talking about this generator specifically, I think it's worth talking about why would you want an inverter generator? I get asked this question quite a bit. Inverter generators, they cost more money and they don't produce as much power in watts as a traditional generator. And yeah, I mean, both those points are true, but traditional generators, they make a lot of noise. And if you need something that is quiet, an inverter generator is the way to go. And I think more importantly is the quality of the power being produced, because if you read the fine print on a traditional style generator, they produce normally up to 20% or higher total harmonic distortion, and anything over 5% can cause damage to sensitive electronics, whereas something like this, it's rated at 1.5% total harmonic distortion, which is well below the 5% threshold. So something like this is considered very safe for electronics. As far as this generator specifically goes, we'll just take a look at each side and kind of discuss quickly what's what. There's not a lot on this side, but there is an access panel held on by two screws, and behind it is where you would find access to the oil fill. So we'll check that in a minute. I'm sure it's shipped with minimal oil, so we'll need to top that off before trying to start it. Also, the model number, 2400P. Inverter generators, they always list the surge watts on the unit. 2400 is not the continuous rating. This is rated at 1800 watts continuously. If you go over that, you're only going to be able to do that for a very short time before the inverter shuts down the power or you stall that engine. Up here we have access to the spark plug if you need to check the gap or change it out. And you can also get a glimpse of the fuel tank. It's actually above the engine, which is a good thing. Some of the more expensive generators, they put that tank lower so that the generator is physically smaller. But by doing that, they have to add a fuel pump. And the only way to prime that pump is to pull the engine over about 10 times before the pump is primed and the carburetor is full, making it pretty hard to start. But something like this, you just turn the fuel valve on, you wait a few seconds for the carburetor to fill, and you should be able to start it in 1 or 2 pulls. On this side of the generator is where you have your status lights and your outputs, as well as control for the eco mode. Now, these status lights are very standard on inverter generators. You have the green light, which indicates you have power output, the overload light, and the low oil light. This also has an extra meter. I don't see that often, but this will show you the voltage out, I think the amps out, the frequency, and the amount of time that the engine has been running. The eco switch controls whether the engine can throttle down or not. Usually you want to have that on to make it more quiet and save on fuel, but if you know you're going to be putting a large load on the generator, you want to shut that off in advance to give the engine a chance to power that load. There's also DC outputs. We have a standard cigarette style output there, and two USB outputs here rated at 2.1 amps each. And on the bottom, we have the two 120 volt AC outputs. And on this side, we have the starter recoil. This is a manual start unit. And we also have the control knob. This performs several functions. It controls the fuel valve on and off. It controls the choke when you move it to start. And when you turn it to stop, it kills spark on the engine. And up here is a fuel cap that is vented, also pretty standard. So when running, you want to make sure you have that set to on so that the tank can breathe and let fuel down into that carburetor. So let's pull the panel off on the other side and check that oil. Also included in that box, we have a user manual, a toolkit, which I'll use to open up that panel. We have a container for filling the oil, which is a good thing because it can be a messy job, especially on inverter generators. And we also have this cigarette style plug, which can be used to charge a battery. So in the toolkit, you have a plug removal tool and a screwdriver. So let's use that to get this panel off. Come on. Yeah, looks to be a pretty good setup. We have access to the air box right up front, as well as the carburetor. It looks like it can be removed without having to uninstall the plastics. I can see the valve cover as well. That is obstructed, so it would be a bit of work to adjust the valves. And this is the oil fill down here, and it looks like it has decent spill protection. A lot of times this is not designed very well, so if you overfill that oil, it goes right inside the case. But this one, I don't think we're going to have that issue. And yeah, we definitely need oil. There's just a little in there for shipping. So I'm going to put some 30 weight mineral oil in there for the break-in. You don't want to use synthetic until you've broken the engine in. So let's top that off and get it outside and break in this engine. Yep, that should do it. I'm going to pull the spark plug out and just get a little bit of oil in the top end. I don't want this to start dry. I want to give it the best chance possible during the break-in. And this is just a magnet. I'm going to use it to hold the spark plug in this removal tool, because there's actually a plastic shield that surrounds the engine, which guides the cooling air. But I could see a scenario where the plug potentially could fall and drop somewhere where you can't reach it. That should be enough. It's going to cause the engine to smoke for a few minutes, but that's actually a good sign. It means the top end has plenty of oil. Pull the engine over a few times, get that oil spread around. Before I close this back up, I want to double check the calibration of this knob. I have seen other generators where the calibration's off. When you put it to run, it's actually either still choking the engine or the fuel valve is so far shut off that the fuel stops flowing and the generator stalls out. So this one, yeah, it'd be a good idea to check, because when I put it to stop, you can see it goes way past the stop position, and that's where it kills the engine. And when I go to start, it doesn't actually make it to that position. So my concern is when I move it to run, is the choke still on or is it completely off? So let's turn this around and double check. So hopefully you can see it. The choke is right there. I'm going to turn this to start, which should have it fully choked, and it is. So I'm going to turn the knob back until the choke stops moving. Which is right there. And that is set to stop. So yeah, the choke calibration, it is off. And I think that's evident by the fact that we don't even get to the start position. So I'm going to make an adjustment on that cable so that run has the choke fully disengaged. I think that's a lot better now. We're in the start position. It is fully choked. We'll turn the knob until the choke stops moving, which is right there. And it's in the run position. So, good. Before I can load test this, I need to break the engine in. And there's a lot of different ways to go about it. Every manual you look at will tell you a different way of doing it. I think the important thing to remember is that most small engines, they don't have oil filters. So you don't want to leave the oil in there very long. You want to change the oil because as it's breaking in, little bits of metal are going to be flaking off into that oil. So my plan is just to start it up, let the engine warm up, and then I'm going to put a 40% load on it for about an hour, change the oil, and repeat the process. So after about 2 hours of break-in and 2 oil changes, we should be ready to do some testing. I moved the generator over into the shade. It's always a good idea to run these in the shade just to keep the electronics in the engine cooled so nothing overheats. Anyway, it looks like we're in pretty good shape. It was easy to start. The smoke burned off right away and the engine sounds good. And it looks like we do have power output. You can see the green light and the display right here. We're at 125 volts, 59.7 hertz, 0.2 amps, and it's been running for 0.3 hours. But yeah, this light actually is backwards. The green light should be up here where it says OK, and the low oil light's usually a red light. So this needs to be flipped around. We'll take a look at that in a bit. Should be an easy fix, but yeah, we're at the 0.3 hour mark, so I think I'm going to get out the space heater. I'm going to put a 750 watt load on it, which is about a 42% load, and just run that until we hit the hour mark, maybe a little bit past, and get that oil changed. Without a load, we're at 123 volts, 59.9 hertz. I'm going to load it up to 750 watts. Usually, if you're going to turn a load on more than 50%, you should turn that eco switch off because you might stall the engine, but let's try it and see if it can stay running. Yeah, no problem. 121.5 volts, 59.9 hertz. Just past the 1 hour mark. No issues to report. So I'm going to take the load off the generator, let the engine cool down a bit, and change that oil. And there's a look at the break-in oil. Not too bad, but you can just see a little hint of metallic in there. And that is to be expected when an engine is being broken in. And that's why you want to change the oil a couple times the first few hours. So I'm just going to refill it, bring it back out, do the same thing for another hour. And I'm going to pause it here. I'll just turn you back on in a second when the engine's fully broken in, and we can start the testing. Actually, let's see if I can fix this while I'm in here and flip it the correct way. I would say that's a no. The lights are right here, and that's the module that controls them. And it's only secured by this one bolt right here. So to correct the problem, I'd have to rotate this 180 degrees, moving the location to bolt it over here. And there is nothing to secure it. So yeah, I would say either the manufacturer of this part got it wrong, or whoever made that label. You know, either way, I think it's going to have to stay the way that it is. We're at the 2.5 hour mark, and things ran as expected. Much cleaner oil the second time around, so I think we're ready. I'm going to start off easy on this one and just test the output to see what the sine wave looks like. For comparison, this is the sine wave of the utility power coming into my house. And you can see it looks pretty good. It's a little distorted both on the top and the bottom, and it's not quite smooth on the peaks like it should be. So this is a pretty clean wave. You know, I expect the inverter actually to do better. So let's get it outside. I'm going to start with no load. We'll see what it looks like we'll do 750 watts and then 1500 watts. So you can see the output looks very clean without a load. Let's try 750 watts. Yeah, it looks very good. Let's bump that up to 1500. Yeah, looks good. Going to do a very similar test as far as the loads go, but this time I'm going to measure the sound output using this sound level meter. Now I am standing 23 feet away, and we'll see what the output is with no load, 750 watts and 1500 watts. Right about 55 decibels without a load. It's right about 63 decibels with 750 watts. And just to put that into perspective, when I'm talking, it's around 70 to 75 decibels. At 1500 watts, we're at around 71 decibels. I'm going to do the same test with this Yamaha inverter generator. Now, I expect this one to be quieter. It is 3 times the price, and it has more sound insulation inside the unit. But how much quieter is it? Let's find out. At no load, right at about 53 decibels. At 750 watts, we're close to 58 decibels. And at 1500 watts, we're at 65.5 decibels. The Yamaha, it did as expected. It performed a little better. It was about 3 decibels more quiet across the board. Anyway, now we get to the fun part. I am going to load test these and bring them right up to the max and beyond. You know, both of these have a 79cc engine. They should perform in a very similar fashion. The Yamaha is only rated at 1600 watts, whereas the ERAYAK is rated at 1800 watts. So I'm going to start With the Yamaha, we'll bring it up to 1600 watts, and then I'll keep going until either the engine stalls or the inverter shuts down, and we'll do the same for the ERAYAK. See how it compares. Let's give this a try. I'm going to use the space heater to bring it up to 1500 watts. And then I have these 4 lights here. They're 70 watts each. So if I turn on 2 of those lights, that will exceed the 1600 watts. And I'll just keep going. I'll turn on all 4. That'll bring it to 1780 watts. And then I have 1 extra there I can turn on if it makes it that far. The light on the Yamaha, it does say overload. Let me shut this one off. So that overload light went off. It seems happy enough, running at 1780 watts. Not bad. Let's try the same test with the ERAYAK. Doing pretty well. I'm over the rated load. There's no overload light, though the engine speed is struggling to maintain speed, so I probably can't do this for long. So let's bring it just back below what it's rated at. Well, guys, that's pretty much it. I mean, this generator, it does what it says. It produces quiet, clean power and can pull up to 1800 watts. So overall, not too bad. If you're interested in finding out more about it, I'll leave that down in the description. So I hope this video helps someone. Thanks for watching.